Good evening, everybody. Welcome back to vBrownBag. Very exciting session tonight. We're going to hear about vSphere 7 with Kubernetes for the vSphere admin with Mike Foley. But before we do, a few quick notes. This is an interactive podcast. If you're watching this live, please feel free to interact with us. Use the Q&A in Zoom, please. If you use the chat, we may see it. We may interact with you there, or we may miss it. So please remember to use the Q&A, or you can use the hashtag vBrownBag on Twitter. We'll be watching that as well, and make sure to get your questions answered tonight. Also, a reminder that we have multiple show times. Check out these ones on the right-hand side here. If you live in a different time zone, or just Tuesdays or Wednesdays, what day of the week is it? Wednesdays in general don't work for you, then check out one of these other times. And also, if there's any episodes that you missed, didn't get a chance to watch this live, check out our YouTube channel. Pretty easy to find, just vBrownBag on YouTube. I'm Ken Nalbone, and once again, joining us tonight is Mike Foley. I'm going to hand it over to him now to hear about vSphere 7 with Kubernetes. So let me stop sharing.
All righty, let me get my sharing going here. All righty.
All right, looks good.
Excellent. So some of you may know me over the past 7 years or so. I was doing a lot of work on vSphere and security. And a number of months ago, I had been doing it for about 7 years ago, and Bob Plankers kind of stepped in when I was sick last year, and he got right up to speed, and I was ready for a new challenge. And so I picked up vSphere Kubernetes a couple of months ago. And right now I'm learning as fast as you guys are. And so I figured I would create content that kind of brought you along at about the same speed as I'm going, or at least hopefully, maybe you're going faster. So we'll start from here. This is my vSphere with Kubernetes tech deck. And the way I'm approaching it, there's a lot of folks out there that are diving deep on the Kubernetes side, or on the storage side, or on the networking side. I came into this and said, what about the vSphere admin? Let's kind of, bring him or her up to speed on what can help them do their job. If you have a DevOps team that is looking at building their own Kubernetes environment, they're saying, oh no, we've got to do everything native because it's the fastest way, so on and so forth. You already have a tried and true infrastructure. Let's talk about how vSphere or Kubernetes can meet the challenges and actually get you along a lot faster. So let's first start out with what an application has been and what it's changing to. Most applications today running in a virtual environment are separate virtual machines. So you have an app running on a virtual machine, a database running on a virtual machine, the web tier running on a series of virtual machines. But when you start going into these new modern applications, they're much more distributed. So we will have something like a Kubernetes cluster, which is the management or control plane for managing containers and other things. I'll get into that in a little bit. And so that's managing my container environment primarily today. I might have some systems that are running just serverless functions. I might have virtual machines, vGPUs, HANA databases. Everything is getting all mumble jumbled all over the place. So if we break down Kubernetes native applications, we're talking about a control plane and worker nodes that the containers then run on. In VMware, that's a Tanzu Kubernetes grid cluster. That's what a lot of folks are using today. But I might have virtual machines. As I mentioned earlier, I might have databases and serverless functions. On either side of these, of this new paradigm in applications, is the DevOps / infrastructure consumers. They want to be able to deploy apps. They want to operate it on day 2. They want their tool of choice. They don't want to necessarily have to learn infrastructure APIs, things like that, because they want to be able to move their workload from vendor A to vendor B and not have that lock-in. But then on the right-hand side, you have the vSphere admin. And the vSphere admin traditionally is charged with ensuring availability, ensuring security, delivering quality of service, managing cost control. So you have the gee whiz new cool stuff on the left. And if anyone's been in this industry for any period of time, there's always the gee whiz new cool stuff and poo poo on the old stuff. But it's the old stuff, quote unquote, that has already passed PCI, has already has backups nailed down, already has all of these infrastructure things done already. And that's where you really start seeing the value of being able to service the DevOps infrastructure consumers on a proven infrastructure. So how are they connected today? How do they get their job done today? How do they communicate today? Today, the DevOps person files a help ticket, it goes into your help request, and the vSphere admin acts on the ticket. So DevOps person says, I need a new ingress address for my application. Okay, that's going to take 2 weeks. DevOps person will find some other way to get that done. Maybe a whole other infrastructure that they built themselves. That's where we don't want to be as vSphere admins. We want to be able to streamline this. And if you look at streamlining this, vSphere with Kubernetes really goes a long way towards meeting the self-service needs and the governance needs. So let's talk about the self-service needs. The self-service needs. I, as the DevOps or infrastructure consumer, I use a YAML file, which is the way that you communicate with Kubernetes, and I declare I need a Tanzu Kubernetes cluster. It needs to have 3 worker nodes, small class, and running this distribution of Kubernetes. Or I need a function or a series of functions. Or I need eventually a virtual machine. Or I need a HANA database. The big thing here is that the DevOps person doesn't have to know how to create any of this at the infrastructure level. They are just declaring what they need and sending that to Kubernetes to make it happen. But that sounds like, okay, they're sending in YAML files left, right, and center and creating a whole bunch of things, Mike. How am I, as the vSphere admin, going to get control or governance around that? I really can't deal with the wild, wild west. We have production that needs to get done. And that's where we roll in vSphere namespaces. So here I've created a namespace, and think of a namespace as a resource pool on steroids. So a vSphere namespace is the sandbox that you're going to give the DevOps team or person or some other entity control over and say, here's your sandbox, go for it. Within the vSphere client, you can see the ability to see the status of a namespace, set permissions, deal with storage, and deal with capacity and usage. We're going to go through each of those. So when you start thinking of it from an application standpoint, I've created a namespace. I've reserved 128 virtual CPUs and 1 terabyte of memory. Of course, everyone on the call is now laughing hysterically that anyone would even give that much to anybody, but whatever. But also within the namespace, I can maybe someday be able to do things like encrypt all persistent data, disallow all ports but 443, audit all developer changes. Maybe I want to set my availability. Maybe I want to set my access controls. So users in group app admin have write ability. Users in the ops team have read only, and I'm going to be able to disallow MySQL. Most of these things are already there. Some of them you may see show up in, moving forward. So what that really gives you is that ability to say, here you go, here's your environment, and do what you have to do within your environment without interfering with other environments. So if I'm in namespace A, I cannot see what is in namespace B, C, or D. So there's my isolation from a multi-tenancy type of standpoint. You're already familiar with how resource pools work. Each namespace is backed by a resource pool. So it's not really a question of, oh, but how many, how can I ensure that everyone gets what they need? You've been doing that already for many years. So for example, I can set within the namespace the resource limits of CPU, memory, storage, etc. From the multi-tenancy standpoint, as I mentioned, each namespace is its own resource pool. You have full resource isolation with quota for CPU, memory, and storage. And all workloads in the namespace are bound by the namespace quota. That means TKG clusters, vSphere pods, eventually virtual machines. So namespace permissions, I can select my AD group. I can select the name or group. And then I can select the role, whether I view or edit. Now, the question around the view permission, you could have a namespace where you've worked with the developer lead to create an environment for, say, an offshore group or person to use. They now have their own Tanzu Kubernetes cluster and maybe a service or something else all living within that namespace. If you set the role to view, they can use the resources within that namespace, but they can't create new resources within that namespace.
Hey, Mike.
So if you want to limit them, that's one way of doing it.
Hey,
Ken?
Mike, we did have a question. Graham was wondering, when you're talking about resources, are network resources configurable too, like network I/O control when it comes to?
Let me take a really quick look over on my environment over here. I think that I'm on the wrong VM. And look at a namespace. And I believe you can create, there are network policies. I believe those network policies are actually created within NSX today and then bubbled up into the vSphere client. I just happen to have a namespace that doesn't have any network policies set, so I can't show you that on the screen. It's just, there's nothing there at the moment. But yeah, you can do a number of things at the NSX level, and then that bubbles up into the namespace. Does that answer the question? Okay, great, thanks.
And then we have another question here.
Sure.
David is asking, he says, I believe TKG currently requires VCF with SDDC Manager. I've heard the same thing. Does the base Kubernetes support with native pods also require VCF, or does it work with vSphere with or without vSAN?
Oh boy. Okay. Um, let me be very clear. So today, the delivery mechanism for vSphere with Kubernetes, remember I said today, the vSphere, that question went away. Okay, there it is. The delivery mechanism for vSphere Kubernetes today is via VCF, VMware Cloud Foundation. The SDDC manager makes setting up, installing, and configuring all of these complex pieces extremely easy. Trust me, for someone who went from NSXV to NSXT and had to deal with things like MTU sizes and everything else, not only within my own environment, but within the physical switches that IT was managing, it just started getting really hairy. And boy, was I hoping for an SDDC manager at that time. It wasn't ready then. So base Kubernetes support on the on vSphere Kubernetes shipping today has support for vSphere pods and which were formerly called native pods, and TKG clusters. You can spin both of them up. Does require VCF today. Talk to your sales guy, and maybe there's other ways of dealing with that, but the party line today is VCF. And then vSphere with or without vSAN. vSAN is not a requirement of vSphere with Kubernetes. vSAN is a requirement of the management control plane of VCF. Just so we're clear. So that's not a Kubernetes thing, it's a VCF thing. Clear as mud? All right, we have two other open questions. Yes, VCF is available on vMug Advantage, and I believe vExperts have that as well.
That's correct.
And Chin has a question. I am a noob here, but is there a way to expose or advertise the capabilities of a namespace to the developer? Level of security, performance, data protection capabilities, capacity available? That would be a Kubernetes thing. I personally have not dived into that, but I do believe there is a way within using the kubectl command to get much of that information. If not, it will probably show up in an update. All right, I'm going to move on. So the Tanzu Kubernetes Grid Service provides a service within vSphere with Kubernetes that allows you to create Tanzu Kubernetes clusters running on top of vSphere with Kubernetes. Now, one of the components of vSphere with Kubernetes is something called the Supervisor cluster. And I'll dive into that in a little bit, but essentially that is a Kubernetes cluster that allows you to run vSphere pods and TKG clusters. So from a DevOps standpoint, if I want to create a Tanzu Kubernetes grid service within, if I want to create a TKG cluster running within my namespace, it's a kubectl command to create that. Relatively straightforward. vSphere admin, on the other hand, can define the templates that are used, the versions that are used, and the resource quota. So that's where you're getting your governance. Please continue with the questions. I love getting the questions, even if I can't answer them all. The vSphere pod service, same thing. I want to be able to create a vSphere pod that will run, and we'll dive into vSphere pods in a moment. But the vSphere pods are going to give you stronger security and resource isolation, performance advantages, a serverless experience, and the vSphere admin gets application-centric management and workload visibility. When you are running a TKG cluster on top of the Supervisor cluster within the vSphere client, you see the TKG cluster, but you don't have visibility further into what's running within that TKG cluster. vSphere pods, you get that enhanced level of visibility into what's actually running within there. So vSphere pods. I created a blog article a couple of weeks ago called vSphere Pods Explained. I would encourage you all to read it, and I'll provide a QR code at the end to my blogs. A vSphere pod sometimes is referred to as CRX, which is Container Runtime for ESXi. It's a combination of technologies that provide a container-like experience. This is running containers on the ESXi. But how do we do that? We are really actually running an incredibly optimized virtual machine with a incredibly optimized kernel and a init process tuned to start really fast, like milliseconds. And on top of that, it runs Linux containers. So when we were going through the discovery process and creation of all of this, we looked at the VMX process. Now, the VMX process, if you logged into ESXi and you saw a bunch of processes working, each VM is backed by a VMX process. The VMX itself is highly configurable and very lightweight. We made some, we customized it a little further with some code changes and created some default configurations for vSphere pods. So when we boot up a vSphere pod, the VMX actually pre-populates the virtual machines, that virtual machine's memory with the Linux kernel. There's no BIOS. The Linux kernel is executed directly, and no I/O necessary for boot. And what's really cool coming from a security background is that the Linux kernel that is shipped is provided as part of the ESXi distribution. It's already packaged in a VIB. And of course, as you know, all VIBs are digitally signed. And as you know, if you enable secure boot, you can validate that that VIB has not been tampered with. And as you know, if you enable TPM, you can report an attestation, create an attestation report that says secure boot ran, that says everything is cool. So the Linux kernel itself is essentially tamper-proof. Now, kernel updates are going to come as part of ESXi updates. And this runs really, really fast. The whole issue that you heard, 1 or 2, 3 years ago of, yeah, but running containers on VMs is too heavy. This blows that argument completely out of the water. So, question from Graham: what's the update patching cadence? You'll obviously your regular ESXi, your regular vSphere updates, update 1, update 2. and then you'll see interim patches between those major updates. You may even start seeing things coming out on a more regular cadence than that. Hopefully that answers that. I don't know how much more I can share at this point, but as soon as I know, I'll be sharing. So let's look at bare metal containers. On a bare metal system, I have a Linux kernel, the container engine, and a whole bunch of different containers. I have shared kernel, shared networking, shared memory, shared storage, and oh, by the way, shared file system. I don't like to share. Coming from a security background, I really don't like to share. There's just too much that could go wrong, in my opinion. So let's talk about vSphere pod security. Each vSphere pod has its own Linux kernel. So you have a unique Linux kernel instance per pod, highly optimized. You're not running a full-blown Linux OS. All you're running is a highly optimized Linux kernel. It has a whole bunch of stuff pulled out of it. It doesn't need a VGA device. It doesn't need USB devices. It doesn't need a whole bunch of other things. All of that stuff, when that Linux kernel was built, were disabled, or not built as part of that kernel. And it doesn't need to boot when you instance it. Correct. The Linux kernel is preloaded in memory for the vSphere pod. VMX hits power on, and there's not even a BIOS. It just executes the Linux kernel. We're talking millisecond boot time. Not multi-second, millisecond. So here you have containers that are now fully isolated. I now have VM level isolation, because these are essentially virtual machines. And I also can do NSX level isolation. So the ability to really isolate Coke and Pepsi is the same as isolating Coke and Pepsi using virtual machines and NSX today. So the VMX is customized with code changes and default configuration changes. The Linux kernel is provided as part of the ESXi distribution. There's no BIOS. The kernel is executed directly. There's a little, the container engines, there's a very lightweight init process to create /dev, etc. And then the container engine is in there. And then you can run containers within that vSphere pod. These three components, VMX, Linux kernel, and container engine, that is what is called a CRX, container runtime for ESXi. These run up to 30 times faster than pods running in Linux VMs. Now, why are they faster? Do the pods vMotion? You don't vMotion pods, you instantiate new pods. I'll dive into that in a little bit. Why are they faster? They are faster than running a whole bunch of containers on one Linux kernel, because ESXi is, the scheduler within ESXi is so well optimized, and because they are VMs at the lowest level of discussion, it is more NUMA aware and is able to schedule better than, for example, a Linux kernel. So Also, the ESXi the ESXi scheduler is so well optimized for managing the resources that are needed. It will look at a virtual machine and say all of the memory consumed by that virtual machine is physically attached to CPU 0. I'm going to schedule that pod on CPU 0 and not schedule it on CPU 1. I don't believe the Linux kernel has that just yet, or at least not at the level we're doing. So that's how you're getting that 30% faster than pods running in Linux VMs. So today, all of this from a networking standpoint requires NSXT. NSXT is what is going to give you your distributed load balancer. You'll have NSX logical segments. You will have the edge load balancer, tier 1 and tier 0 gateways. The inbound traffic is denied for all namespaces by default. All namespaces are isolated within NSX logical segments. The vSphere pod service objects are all isolated with edge firewall on tier 1 gateways and distributed firewalls on a per VNIC level. And within the TKG cluster, which is a series of virtual machines running Kubernetes, running containers, the networking that's going on in between those TKG clusters is Calico by default.
So my question, Mike, there is, can you use an overlay other than Calico for those VMs, those pods?
I can't talk to you about futures.
Okay, so right now, Calico is the option.
Yeah, correct. Calico is where things are.
Very good.
Okay. The network service allows the DevOps person to do that kubectl create ingress network. They don't need to know NSX. So really, if you think about it from a vSphere admin standpoint, your DevOps people don't need to know the vSphere API. They don't need to know the NSX API. They just declare, hey, create an ingress network. Make it happen. Right? As my wife would say, this is a pay the man situation. Let the Kubernetes gremlins sort out speaking to NSX and creating the appropriate ingress network and making it happen. Within the vSphere client, you have the ability to manage a few settings, but what you'll see in there are things like subnet mask, control plane IP address, DNS and NTP servers, workload network settings, your CIDRs for pods, services, ingress and egress, all of that. If I have the ability within the vCenter client to be able to change some of these settings, like pod CIDRs, like all the 3 CIDRs there, and DNS servers and NTP servers. Anything more than that, and I have to go into NSX. Any more questions on the network side? One of the things I will say is MTU, MTU, MTU. And not only MTUs setting correctly at the physical NIC on your ESX host level and all throughout wherever else within ESX and NSX it has to be set, but you also have to make sure that it's set on the switch level. And one of the things that I was encountering that took a while for IT to find and fix was making sure that you have jumbo frames set between let's just say, but you have two switches, one's doing ingress, yeah, 9,000 everywhere, call it good. Within NSX and segments and stuff, it's 1,600, but at the infrastructure physical layer, yes, 9,000. You have to make sure it's at 9,000 at the L3 routing layer as well. I was having a hell of a time trying to get to my Harbor instance and my download my CLI tools. I would hit the IP address, it would ping. I could trace route. I'd hit the IP address and I couldn't get anything. Come to find out, the routing layer between subnets was still at a non-jumbo frame value. Once that was fixed, everything worked. So yeah, making sure that you have jumbo frames turned on at the infrastructure, switches, routing, and ESX host layers, your life will go a lot easier. So now we're going to talk a little bit about the storage service. As I mentioned earlier, vSphere Kubernetes does not require vSAN. That's a VCF requirement for the management cluster. Within vSphere, when I'm running a container, within Kubernetes, when I'm running a container, I start up a container and I get an ephemeral disk, and that's where it has all my scratch space and stuff like that. When I delete the container, that disk's ephemeral and it all just goes away. But what if I need a persistent volume? So within Kubernetes, there's something called a persistent volume claim. I need this much space that I can then attach to my container. Let's say, for example, I'm running some version of a database and I need a disk to actually store the database. I create a persistent volume. I start up the container. I say create new database on the persistent volume. Now I want to upgrade to the latest version of the database. I would create a new container with the latest version of the database software, and then I would attach that persistent volume to that container. Within vSphere, this is done using something called first-class disks. Within vSphere today, in the 6.7 in earlier time frame, I can create a VMDK, but it has to be attached to a virtual machine, because a virtual machine is a first-class object within the hierarchy of vCenter. In 7.0, disks can become a first-class object within the hierarchy. So now we need something to manage it, something that says, okay, I've created this persistent VMDK. It's living out on this data store, but what does it map to? That is the storage service. So here's the example. kubectl, I want to be able to, I've created my persistent volume, and now I do a kubectl get PVC, and oh, there's my persistent volume. The volume name is PVC, a whole bunch of stuff. If I go to the right, I will see that persistent volume within the vSphere client, and I will see what it's mapped to. Who has claimed that persistent volume. So within the namespace IoT application, running on the pod Nginx pers 646 yada yada, that is the pod that has the persistent volume mapped to it. Does that make sense? I hope it does.
It will when I watch it the second or third time. On YouTube.
Yeah, it takes a little bit to wrap your head around some of this stuff. I totally hear that. I totally get that. Like I said, I only started doing a lot of this a few months ago. But once I started wrapping my head around it, okay, yeah, I get that. now it starts becoming more clear. Can disks be shared between containers? Boy, I really wish I had video up and I could show you my digital VAX cluster systems whiteboard that's behind me. In order to share disks between containers, you'd have to have some type of file system to manage the locking between those containers. I don't think there's anything like that out there right now, but I could be wrong. No, you don't map disks between containers.
That's more of a file services type task, right?
Yeah, that's at the file system level at the on the container. So yeah, to be honest, I believe you have one of those whiteboards. I actually do, and sitting behind me, I have a VAX 4100 that I'm currently in the process of trying to get booted. Okay. Had to throw in something about me being old. So, cloud native storage, vSphere Kubernetes works with all of these different storage pieces or types. It's storage agnostic because a persistent volume is just a VMDK living on a data store somewhere. So that means I can use vSphere storage policies, which then become in Kubernetes something called a storage class. So maybe I have a vSphere policy that says all flash. Well, guess what? In Kubernetes, the developer is going to see when he queries via the kubectl command, what do I have for storage within my namespace? He would be able to see, oh, look, I have an all flash storage class that I can use. So let's see how that looks on the left-hand side of the virtual machine storage policies. On the right-hand side are the storage classes for Kubernetes. So when within my namespace, I select what storage policies are available to the namespace. I can select, for example, the vSphere Kubernetes storage policy and the vSphere Kubernetes storage policy. They map one-to-one. That should be pretty straightforward for hopefully everyone. So the registry service is based on the Harbor project, which is an open source Kubernetes image registry available at harbor.io. The latest version is available at harbor.io. And that is where you're going to store, that is where you're going to store your container images. So rather than your developer pulling down images from a .ru or .cn image registry out on the internet, you would put images in your Harbor registry, and then they would be able to use those directly. So I can do a deploy app and specify what image in the image registry I need to run. The registry service is integrated with vSphere SSO. DevOps users can push images directly into the registry. It's very seamless to the DevOps person in order to use this. The registry configuration is done right within the vSphere client. You would select what storage policy that the files for the registry are living on. You see the link to the Harbor UI. When I mentioned earlier the MTU issue, it was this address. Every time I clicked it, I wouldn't get anywhere until the routing issue was solved. And I can also download the SSL root certificate and maybe load that into my Active Directory if folks want to use that. So how does the developer consume vSphere Kubernetes? if you look at the way, one of the questions I always got was, how can I limit what people are logging into vCenter? Kubernetes is going to be able to address this for a lot of people, especially developers. So today, vSphere admin speaks to vCenter. You know all that. Within vCenter is the supervisor control plane image, a spherelet bundle. I'll explain what a spherelet is in a moment. The workload platform service and the Kubernetes client bindings, the namespaces REST API, the SAML to JOT exchange service for tokens, for login tokens and such. The DevOps person is going to speak to the Kubernetes control plane VM. There will be more than one running. Typically, it's 3. And so they're going to be using the kubectl command to speak directly to the Kubernetes control plane VM. Oh, sorry, the spherelet. So if you were running Kubernetes bare metal and you have a number of worker nodes, they would have something called a kubelet, K-U-B-E-L-E-T. We ported the kubelet functionality to ESXi. Its job is to keep monitoring the status of what's going on and reporting that up to the control plane. If there is a vSphere pod running on that ESXi host, the spherelet is always keeping its latest status on that current in the Kubernetes control plane VM. Within the Kubernetes control plane VM, you'll see a whole bunch of things: Kube Scheduler, API, etcd, all the container plugin, NSX container plugins, cloud storage, cloud native storage, token key exchange, etc. The DevOps person is going to log in using a kubectl vSphere login command. They will download a kubectl plugin, which gives them the ability to then log into vSphere. This should be nothing new to any developer that's using Kubernetes. There's kubectl login plugins for a number of other distributions. So running on the vSphere, running on the ESX hosts would be something like a vSphere pod. I showed that earlier. As mentioned, 30% faster than pods running in Linux VMs, 8% faster than pods running on bare metal because of all that scheduling. So we could have multiple vSphere pods. We could have virtual machines. Those are managed via hostd. You can mix and match all of that stuff running in your environment. Those are all managed via the Supervisor cluster. So the platform architecture is going to look like this. I have an SDDC. I have Supervisor clusters per ESX clusters. I have multiple namespaces. They can be running pods. The VM operator is what starts up the Tanzu Kubernetes clusters and creates the virtual machines that are running there. Within the virtual machines, one of them is a control plane. There's multiple workers. There's Kubernetes namespaces within that Kubernetes instance, and then pods running within that Kubernetes instance. It's like multiple levels of inception. So now we're getting down to the end. There's a number of resources. There's links to my blogs. I have a blog on vSphere with Kubernetes 101 for the vSphere admin, namespaces, Kubernetes clusters, and vSphere pods. My coworker, Michael West, has been doing this whole Kubernetes thing now for quite some time. He has created some really brilliant blogs, very, very in-depth at the Kubernetes interaction level. Like, he did a deep dive on Kubernetes networking that is really a must-read. Just yesterday, I believe, or maybe today, the vSphere Hands-On Labs now has, I'll make the slide deck available via PDF. The vSphere Hands-On Labs has VCF 4.0 and vSphere with Kubernetes available right now. Go to the URL that's that this QR code is showing. In addition, there's some other great vSphere with Kubernetes blogs. David Stamen was in the vSphere tech marketing group. He is now over at Pure Storage, and he is creating some really, really great content. He has a 5-part series on getting started with vSphere Kubernetes that is just, I reference it. Okay, it's that good. Everyone knows Cormac and everyone knows William. They have been creating some really great, fantastic blogs and tools for Kubernetes running on vSphere. William has some scripts that allow you to start up and run a full vSphere with Kubernetes instance. Really, really cool stuff. You really should follow all 3 of them. That's what I have. Ken, any other questions besides slide deck availability?
No, I haven't seen that one. So just a reminder for folks that, you know, you will be able to find all of this content back up on YouTube within 24 to 48 hours anyway. So if there are little things that you missed and you don't know where to get the slide deck, you can always just check out the video. You can scan those QR codes there, just pause it for as long as it takes. That's what I'll be doing so that I can get these links to just put in the YouTube description as well. But pausing a moment to see if there are any more questions that pop up into the chat or up on Twitter.
David, Graham, anything else?
And if you want to be taken off mute so you can ask it live rather than type it,
sure.
Just raise your hand.
I'll just start calling names out. Robert, any questions? Jeremy, any questions?
Looks like people are, glad they attended and saying thank you at this point. So I'm going to say thank you too, Mike. Really appreciate it. Great introduction. Great ways to get more deep dives and learn more at the end there. So I think,
yeah, I mean, one of the things that there's plenty of content out there for learning Kubernetes. Mm-hmm. I don't want to recreate the wheel. My focus is purely on assisting the vSphere admin and trying to get him or her up to speed so that they can head off any shadow IT happening, and that they can go to their developers having an idea as to what the capabilities are. And just remember, if you have any sort of workload that falls under regulatory requirements like compliance, PCI, HIPAA, so on and so forth, and you've already done all of the hard work to get that working on vSphere or to get vSphere compliant to that environment, it makes absolutely zero sense to create up a whole brand new other environment on, say, native bare metal stuff when you could just as easily meet that requirement on vSphere. So that's kind of my rant for vSphere admins is you control far more than you might think you control. You can make solid business cases for moving to vSphere with Kubernetes. So Graham has nothing sensible to say.
Yeah. We got a lot of chit chat now. I think it's time to call it. Everybody enjoyed it. Thank you for your participation, folks. And we will see you next time.
Thank you so much.
Good night.